Okay, so we're going to be looking at rational functions up to 3 degrees. Here I plotted a function where we can just mess with the a value to see 1 over x to the a, where we got 1 over x squared, and 1 over x cubed. So we're going to look at different properties. One is a vertical asymptote, which I have a definition here, and I plotted 3 points just to see what a vertical asymptote is. Then we're going to look at horizontal asymptotes, which have the definition. The horizontal asymptote comes with 3 different rules that work with exponents of the numerator and the denominator. And then we got horizontal asymptotes, which we're going to sit here and look at different kind of and how they change according to their exponents. And we're going to look at the rules. So the first function we have where our exponents is the numerator is less than the denominator. So that means we have a horizontal asymptote at the x-axis or y equals 0. So if we look here at the next function, we have where they are equal. So our rule states that it will be y equals a over b. So 3 over 1 equals 3. And there's our horizontal asymptote. And then our third rule, where the numerator is greater than the denominator, we have no horizontal asymptote. So now we're going to look at a degree 1. So we got a parent function of 1 over x. So now we can just change our sliders and see how a and b affect this graph. So we look at our vertical asymptotes. So if we look, we got a vertical asymptote at 2, and then we got a at -2 and b at 2. So if we change our a, it always keeps the same vertical asymptote. Now once we start changing b, that's when our horizontal or vertical asymptote will change. So if our b is 1, we can change our vertical asymptote to 1, and they're the same values, which is our vertical asymptote. Because remember, it's 0's in the denominator. Or horizontal asymptotes, which I have at y equals 0. So if we change our a value, once again, it never touches right here. Never touches our horizontal asymptote. So once we change b, it still never changes our horizontal asymptote. So our horizontal asymptote, according to this function, will never be anything but y equals 0. Unless our a is 0, then we have a straight line. So that's just, we have no horizontal asymptote because our function will be 0 over anything is 0. So maybe a straight line. So look at our y-intercepts. This function here has 0 y-intercepts because it never crosses that axis. No matter what you change a or b to. Now increasing and decreasing. So we'll see which variables change the increasing and decreasing. So if we look, b keeps the same function, the same graph. So our increase and decreasing will stay the same no matter what value of b we have. Now once we start changing a from positive to negative, you can see that the graph changes directions. So that's when our graph will change increasing and decreasing. Which makes sense because when it's positive until it goes to negative, so it's obviously going to switch sides because that's our numerator. So a negative numerator and then a positive numerator. So we'll look at degree 2 now. 1 over x squared is our parent function. And then we can just change the sliders and see how it behaves. We notice here we got an upside down parabola or a regular parabola it looks like when we start changing our a value. So we'll see how that affects our properties. So now we got vertical asymptotes for this function. So 1 over x squared, our vertical asymptote will be x equals 0, which makes sense because our denominator is 0. So we got to find 0's in the denominator. So now if we start messing with the a, let me change this in. Start messing with the a, no matter what, we still got that same vertical asymptote. Now when we start messing with the b and make it positive, we notice this parabola starting to form, which interrupts our vertical asymptote. But now if we notice the b goes to negative, our parabola is gone. It's only when it's positive when we have that parabola. So when b is greater than 0, we have to compensate for this parabola. So if we notice, we can move this slider to a certain number over here and have a vertical asymptote here, but we also need one over here. So we need to find a number that is a plus or minus so we can have two vertical asymptotes. So we're going to go to Symbol Lab and just plug in 4 as A and 2 as B. So and it shows our vertical asymptotes will be x equals negative square root 2 and x equals square root of 2. So if we go back to Desmos and cover that up and plug in these two and then make A4 and B2, we can see that our two vertical asymptotes, plus and minus square root of 2, satisfies. So our horizontal asymptotes now, no matter what we change A and B to other than 0, we're always going to have that y equals 0 horizontal asymptote. So our y-intercepts is the same as the other one. No matter what you change, you'll never have a y-intercept. So now increasing and decreasing functions. So if we change A, let's just look at A. Once again, it changes direction because we always have that numerator. We always need to look at the numerator, negative or positive, to see how our function is increasing or decreasing. Because when it's positive, it's always this kind of function. It always goes from increasing to decreasing. And then once it goes to negative, it's when it goes from decreasing. So our B value never really changes the whole increasing and decreasing aspect, but our A always will. So now we'll look up to third degree, which our parent function 1 over x cubed. And we can just mess with our sliders again to see how it changes. If we notice, we got a little curve or a little constant right here, which we need to be careful when we look at increasing and decreasing, because the function just don't go from negative infinity to negative infinity, because we have this constant here, so we need to make sure we look at that. So the vertical asymptotes of 1 over x cubed, we'll move it to 0. And then we'll start playing with this. So if we move A, we can see that it looks like it's normal to the other graphs. It just switches direction. So our B value, once again, is going to be the one that changes our vertical asymptote, because it moves it from left to right along the x-axis. Just like the other two functions, the horizontal asymptote will remain the same, because other than 0, it'll never cross that horizontal asymptote. Similar to the horizontal asymptote in the other two functions, they're similar because no matter how you change this function, it will not cross that x-axis. Increasing and decreasing, pretty similar to the other ones. If we look, we can tell that the A is the value that switches it. So if we just look back at all these, we can remember that the A value is what switches the size of these functions to tell whether it's increasing or decreasing. So that is our 4 main properties of rational functions up to 3 degrees.